right, so I've gone ahead and highlighted a few of the important pieces of this question. I went over identifying them in a separate video, so I want to keep these demonstration videos as tight and concise as possible. So I'm not going to go over the key identifying features that tell us that this is a single sample t-test. It's a chapter 9 question, so single sample t-test. We're going to just jump right in. We need to do the full 4-step hypothesis testing procedure. So step 1 of the hypothesis testing procedure is that we come up with the hypotheses. To do that, we need to know that we have a one-tailed test. And for the single sample t-test, we need to know what that expected value is. And that's identified by mu on these questions, all right? So we are going to have our alternate and we're going to have our null. It's a one-tailed test. This is, we're going to do mu, and we put in that population value right there, the population value 20. That's the expected value. We're going to put that into our hypotheses. And it's a one-tailed test, and the researchers are predicting a decrease. That's our research hypothesis. That's our alternate hypothesis. So the researchers are expecting that whatever this treatment does, it should decrease the dependent variable measurement relative to what the population is. So we expect that mu is less than 20. To get the null, we flip the direction of that sign and we put the equals. This means that our hypotheses are mutually exclusive. If one is true, the other cannot be true. And they're exhaustive. All options, all potential outcomes are covered. Step 2 of the hypothesis testing procedure, we need to find our critical value. And there's only going to be one because it's a one-tailed test. And if I draw this out, which I strongly recommend everybody draw them out, right? It's predicting a decrease, which means that our critical value is going to be negative. Now we need to find what that number is, what that cutoff value is. We need that it's an alpha of 0.01. We need that it's a one-tailed test, and we need our degrees of freedom. Degrees of freedom for a single sample t-test is n-1. So there were, I suppose I need that piece of information too, this 15 part, right? So there were 15 individuals, so 15 subtract 1, our degrees of freedom is 14. And then what we're going to do is we go to table B2, and we're going to look here. Proportion in one tail was an alpha of 0.01, so proportion in one tail, 0.01. So we're going to look in this column, and we have 14 degrees of freedom. So we're going to read across here and down here, and that's our critical value. It is negative 2.624. Anything that happens out here, this way, in this tail, we're going to reject the null and accept the alternate. Anything that happens over here, we're going to fail to reject the null, okay? So we'll reject it if it falls over here. We're going to fail to reject if it happens over here. Step 3, we need to calculate our estimated standard error. This question gave us variance, so the formula that we're going to want to use has variance in it. There's no sense in calculating the standard deviation and then calculating it through. We can skip that step because we have the variance already. So the variance was 135. We divided by our sample size, which was 15, and then we'll take the square root. Don't forget to keep that square root until you actually do it, okay? So 135 divided by 15 is 9. We take the square root of 9, and that's 3. Now that we have the estimated standard error, we can calculate our t. The formula for a single sample t-test is m subtract mu divided by the estimated standard error. The mean that was observed is 12.5. The mean that was expected, based on the population expectations, was 20. And then we divide by this estimated standard error. So 12.5 subtract 20 is negative 7.5 divided by 3, which is negative 2.5. Okay? I'm going to take my red pen because it makes it more visible on this diagram. And I'm going to put that value. So negative 2.5. Consider that the middle of this distribution right here is 0. Okay? So 2.5 is in this fail to reject region. So step 4, we're going to fail to reject the null. This can be my evidence. In essence, to interpret it, there is no statistically significant treatment effect. Or you could say 2.5 is not as extreme as negative 2.624. You could say it's not in the critical region. There's a variety of pieces we could put there. Don't forget to come back and do that effect size measure, okay? So now we're going to do that. This is Cohen's d. Cohen's d, the formula for the single sample t-test Cohen's d is m subtract mu. The numerator, the top part of Cohen's d, is always the same as the t-test that it's associated with. And the denominator, the bottom part, is standard deviation. But we don't have the standard deviation. We have the variance. So if we want the standard deviation, we take the variance and we take the square root of it. So we take the square root of 135. Which is 11.62. Keep at least 2 or 3 digits in all of your calculations, including your final answer. Don't go rounding it too much. So the mean was 12.5. Mu that was expected was 20, and we're going to divide by 11.62. So negative 7.5 divided by 11.62. Negative 0.65. This is a medium effect. So don't forget that part, right? It's not just about calculating the value. It also asks, is this a small, medium, large effect? So you need to say which one it is.